Okay, so we're wanting to find the equation of this parabola. Now, people are having trouble getting started because this course is fairly challenging. I mean, this is a fairly challenging task, but it's one that we should be well prepared from everything we've done with transformations and so forth to understand. Still, it's challenging. Okay, well, at first I hadn't sketched these lines, x equals -2 and x equals 2. We just put this down. Nobody really knew how to get started. So I'm going to give you a broad hint here. Red dot for the toolkit function is here. Constructing that function in a 4x2 rectangle, it's going to look like this. I'm abbreviating, that's toolkit square function. Y equals x squared. Now, what do we have to do to that function to get this function? Well, first of all, we have to flip it, right? And then, well, we have to do something else. Even if we flip it, let's go ahead and flip the thing. Here's y equals -4, and flipped, it's going to look something like this. Not very well drawn. Okay, so we should understand that if all the y coordinates become negative, this is what we're going to have, right? So the point -2, 4 will become the point -2, -4. +2, 4 will become +2, -4. And all the other points will become negative, the negative of what they are. And that's going to have the effect of flipping the graph across the x-axis, or reflecting across the x-axis. That's a reflection. Okay, now, if I was to take this graph and shift it over here and up here, what would the equation be? Okay, that's about the right shape, about the right width. Okay, it's not perfect, but what would the equation of this parabola be? Something you really want to focus on if you haven't totally understood it previously, okay? Okay, so, got the answer. Well, I know what the point would be, but I don't know what that does to the equation, okay? Well, this point is, first of all, it's the vertex. And I think you know that that's the point that's called the vertex. But if any of you don't, that's what it's called. Okay, that's what we've been calling it for the last month or so, more than a month. Okay, so it's the vertex. This is the vertex of the toolkit squaring function, or the reflected toolkit squaring function reflected about the x-axis. So up here, this is the vertex. So that the And my question is, then I'll ask is, the horizontal shift of the vertex. You show me some figures. I mean, here's the vertex, right? Well, 2 would get the vertex from here to here. Okay. And 4 would get it from here to about here. Where does it have to go? It has to go from here to here. Vertex is here, now it's here. Put a red dot on it just to make it even clearer. Vertex has to go from here up to here. So it has to move horizontally and it has to move vertically. So can you write down what you think the horizontal shift would be? And what's the vertical shift? Some people are having a little trouble telling me what the coordinates of this point here, the vertex of the toolkit squaring function. So think that through if you're watching the video and see if you could tell me what the, now some people can tell me, some people are having trouble with this. And this is something we got to remedy because it's basic to the whole coordinate system, okay? And it's easy to remedy because I simply asked, okay, what is the x coordinate of every point on the y-axis? Well, I got the answer from everybody. It's 0. Everybody knows it's 0, okay? And what is the y coordinate of every point on the x-axis? Well, it's 0. I mean, here's -4, here's +4, there's 0, right? Y is -4 here, -4 here, y is 0 here. X is -2 on this little line, x is 2 on this little line, and the y-axis is right in the middle. Well, right in the middle between -2 and 2 is 0, and that's really our whole starting point when we graph anything, when we talk about the coordinate system. So, big deal. Okay. Now, if this point is seven 12, then how far do we have to move over from this point until we're on the x equals 7 line? You show me with your fingers? Yeah. I was hoping you'd open that other hand. You had to put the pencil down. Didn't want it to fall. Okay, very good. Okay, so your horizontal shift is h equals 7. And we call that, we use h for the horizontal shift. Usually that's a standard notation that you see in most textbooks. Not everybody will use that notation, but for the most part, that's what we have. And what's the vertical shift then? Can you show me? Yeah, 12. Okay. Okay, let's put a big box on this statement and this statement. So now we know the horizontal and vertical shift. It's necessary to get a function with vertex at the origin over here. Only problem is this function is a lot wider than this one. So we have to horizontally compress this function. We have to squash this function down until its shape matches the shape of the given parabola. For a useful piece of chalk. Okay, well, we'll take what we've got. Okay, well, then what we need to do with this is we need to spread it out. Maybe about like so. So now this would fit if we turn it upside down, like so. I didn't draw it quite right. I drew it a little too wide, but you get the idea. And this one should have been in yellow. We have a couple of vertically compressed parabolas. They're a little too compressed. Now, I didn't intend to draw them too compressed, but I just went and did it. And, having done that, I will make use of that fact, okay? So if I was to take this thing and shift it over 7 and up 12, it would be a little too fat, right? Can you see that? So how are we going to get just the right compression? But you understand that the toolkit function has to be squashed down a little bit, okay? And then flipped, and then horizontally and vertically shifted. Okay, well, in order to figure that out, we can use this point. This point, what are the coordinates of this point? What's the x coordinate? It's 0. Right? And what's the y coordinate? Yeah, that can read lips. Everybody said 7 or held up 2 hands. Okay, so we know that this point is 0, 7. Oh boy, I don't have a good place to label it. I have to write it a little smaller than I'd like to. You see that okay? Okay, that's the point 0, 7. Now the point 0, 7 is on the graph of our function y equals f of x. Now I labeled this thing y equals f of x, and now I've almost hidden the labeling. Make sure we understand that this is the f of x function, right? Okay, so horizontally compressed, horizontally shifted, and vertically shifted. From the toolkit function. So, yeah, okay. So we'll continue right here. I said horizontally compressed. I left out a word. And that may be almost impossible to read, and reflected. Okay. Y equals AF of X. You know what? I call this function F of X. I want to call this function G of X. We haven't really used the F of X yet, so I only have to change it in a couple of places. Okay, it's G of X now. And this one is X. This is what we're trying to do. We're trying to find the formula for this thing. Okay. Y equals AF of X multiplies every Y value by A. For this function, well, I'm not even going to say it. We'll get it when we do the algebra. Stretching or compressing Oh, when I say possibly flipping it, by flipping, I mean reflecting it across the x-axis. It's quicker to write flipping, takes up less board space. But that's what I mean by flipping. Now, in this case, it does flip, which means that A is going to have to be negative. We know that. Okay. But we don't know what A is going to be. We don't have a good way of figuring that out looking at what the information we're given. We do have a good way, but we're going to develop that. And it's actually fairly simple. Okay, well then, it flips us horizontally 8 units. It shifts the AF of X graph 8 units. and it shifts vertically k units. Now, what do we know about this graph? We know that h is 7 and k is 12. In order to get h and k, all we need to do is look at the vertex. Now, we haven't mentioned that, we've got to start f of x is the toolkit function. So I'm just going to identify that function as our f of x. Implicitly, that is our toolkit function. This one right here, the narrow one in blue. This one here is vertically compressed. This one here is reflected. This one here is vertically compressed and reflected. Where does that leave us? It leaves us with a reasonably simple equation to solve. Well, if f of x equals x squared, f of x minus h is quantity x minus h squared. You simply have to understand how function notation works. I've said this about 1,000 times, and it's sinking in, but hasn't quite sunk in, I don't think. If we replace x by x minus h, if we want to get f of x minus h, we've got to replace x in the definition of f of x by x minus h, meaning we've got to replace this x by x minus h. So it's x minus h squared with parentheses around the x minus h, because we don't want to do x minus h squared, which means we don't do anything to x, we just square h. So parentheses isn't there, only h is getting squared. Parentheses is there, the whole x minus h has to be squared. Okay, so f of x minus h equals x minus h squared. Then it's pretty easy to write a f of x minus h plus k. The a goes out in front. F of x minus h, which is just x minus h squared, goes here, and then we add k. We have to understand every step of that. You have to understand that k does go inside these parentheses. The a doesn't go inside the parentheses. We're just taking a times whatever our expression is for x minus h, and then adding k. That's all this says. And this is g of x. We okay so far? Understand those steps? Make sure you review them. Make sure you think them through until they really sink in. Okay, so all this is off here. What we've obtained from all that is that yes, it is a f of x minus h, but f of x minus h is x minus h quantity squared, and then plus k. All right. Again, with h equal to 7, k equal to 12, the easiest thing in the world for a quadratic function is to figure out what h and k are. A unknown. Although we know that a is negative, and we know it's less than 1 because every y value in this one is a lot bigger than the corresponding y value on this one. So we have to multiply the y values by a number less than 1 to get a smaller value, a lesser value. Okay? How to find a? Well, we know, what do we know? We haven't used the 0.07. Okay? Okay, we want to plug that into y equals a times quantity x minus h squared plus k. That a was a little small. But now we know h is 7. We get y is 7, x is 0, and then the plus 12 is there. You can solve that for a. Okay, now some people have just a little trouble with this, not a whole lot, but there are a couple of wrong steps that I see people taking. So I'm going to explain exactly how this is solved for a. You get 7 equals 49a. Because 0 minus 7 is -7, and -7 squared is positive, you get a positive 49. So somebody got a negative 49 there. Okay? I think anybody that got a negative 49 understands what they did wrong. Okay? And you just got to be careful about that. But the right idea is to square whatever this is. So right idea, but wrong execution. And then we have plus 12. Okay, well, that is a simple linear equation that's solved by adding -12. First, by adding -12 to both sides. Actually, first thing I'm going to do, and it's not necessary, now usually I like to line up the equal signs, but I don't have room. So the equal signs aren't quite lined up, but you really want to try to keep them lined up because at least one person made a mistake by not lining up the equal signs. Okay? And then you want to isolate a, so you have to get rid of that 12 on this side. So you're going to add -12. Oh, heck. -12 equals -12, both sides. All right. Now, the negative 12 is lined up with the 12, but even if you lined up the negative 12 with the 49a, you couldn't subtract 12 from 49 and get anything that's related, even remotely, to the solution of this equation, because 49 is multiplied by a, and you don't know what 49a is. You do know what 12 is. It's 12. And if you add negative 12 to it, it's going to be 0. Okay? Now, one of the mistakes I saw was somebody misaligned the equal signs and tried to add negative 12 to 49a and then negative 12 to 12 and didn't do anything to the 7. Okay? Just by misaligning the equal signs and not really understanding what the principle is here is that if you add the left-hand side of an equation, if you have two equations, add their left-hand sides and add their right-hand sides, you still have an equivalent equation. In other words, you don't change the solutions of the equation. If you try to add that negative 12 to the 49, you're going to change the solutions and you're not going to get anything that corresponds very well at all to what we need. Okay, now I'm pointing over here to what we're after. Well, it's still there. We can see it. Okay, so that's why I say now in this step, we don't add 12 and negative 12, and we don't cross them out. We do this. We write out the left-hand side, 49a plus 12, and then that added to the left-hand side of this equation. So this left-hand side of this equation added to the left-hand side of this equation gives us this. And the right-hand side added to the right-hand side gives us this. There's no mistake there if we can just copy things down correctly. And then we know that 12 minus 12 is 0. So we're going to be left with 49a equals negative 5. And just to be complete, I don't really have room, but I'm going to kind of squeeze it in. We got 49a over 49. And let me make sure the camera picked up all of that. Shoot, I can't even find it on the screen, but there it is. Okay, we got it. Okay, 49a over 49 equals negative 5 over 49. So a equals negative 5 over 49. Sorry, I had to write that small, but it is pretty clear on the screen on the video. So I think everybody's sitting close enough today that they can see that. At least they're saying that they can see it. So if you think of lying to me or you think you can see it, and you don't look like somebody who could lie. None of you do. Okay. Of course, people will surprise you with that. I don't think so in this case. Okay. Well, we've got A. And we know that y equals a times x minus 7. And I didn't write the square here. And I've seen people fail to write the square. It's really important. Okay. To write the square. A times x minus 7 squared plus 12. And we just found out what a is. So we got our formula. We just replace a by negative 5 over 49, and we've got it. Now I've got the problem, and I don't really have room to write that because I don't have any place for this to go. So I just have to take this board away for a minute. Now I'm writing out a whole lot of stuff here. Negative 5/49, negative 49 over 5. Thus, y equals g of x, because where did we get the 7, negative 7, the 12, and now the negative 49, 5/49? We got that by using the information on this graph with the goal of getting the equation for the graph of g of x. I labeled g of x here. I'm going to label it here too, because this label is a little bit harder to see. But we took this information, we used what we understand about shifting and stretching transformations. We, I hope, came up with a good explanation of why a vertical shift and a vertical stretch and a horizontal shift and a vertical shift give us a function of the form y equals a f of x minus h plus k. And we've developed that over a period of a month with the transformations that we've worked with. Okay, we have y equals g of x, then, okay, again, y equals a times x minus 7 squared plus 12, using the information from the graph, solve an equation for a. We conclude that y equals g of x equals whatever we've written here, but we replace a with negative 5/49. And there's our equation. And that's the entire process that we use when we have the graph of a quadratic equation. We're not going to make it, are we? So I'm going to complete. I need more room. There it is. This is the equation. This is what we end up with after going through all that. Now, I recommend, if you don't understand this, and most people don't in pre-calculus or in this support course, that you write out the words that I've written out here. Whenever you do one of these, go do one, find one that you might have missed in the last homework assignment. And even if you got them all, reinforce it now, because it's going to be a big deal on the midterm exam coming up in a couple of weeks. Reinforce it by writing out words. And if you want to, send me a picture of that, but I'm not going to require it. But if you're not sure that you totally understand it, it would be a really good idea to do that on at least one problem. On the assignment that was due last time, you had a number of graphs. And you were asked to find the function. And somehow people did fairly well with this, but when I ask a question like this, it doesn't transfer. Okay. So this is why everything is the way it is. And you really want to focus on that and get that down, because if you do, you've got a really good piece of knowledge there. Probably never do you any good in your life, but you've learned to think through it. So your thinking process is better. And of course, if you take a calculus class, it's going to be very handy to understand this framework. Even if you take a statistics class, which is not quite as demanding mathematically, you're going to be able to think it through better, and you're going to understand the formulas you're using a little better. Okay, now there's the benefit. I keep making this statement, and I'm not sure how things are going to unfold. Nobody is with artificial intelligence. If you're going to work with artificial intelligence, you darn well better have the best thinking skills you can develop. And one of the best ways to develop thinking skills is this. Know others and understand great literature. And there are many of them, be able to write without AI writing it for you. Understand history, understand everything you can, and think through it as deeply as you're capable of doing with the time you have, given all the other demands of life. Okay, well, going a little beyond the mathematics here, but there's the mathematics, and that gives you a little context of why, at least in my opinion, a really good idea to master this. Okay? Okay, well, there's the whole analysis, starting here and moving to the left, here, 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 and here. I didn't have room to include what we do when we find that A is -5/49, but we just plug it in here. We replace A by -5/49, we get the equation that I've written on the board. And just for completeness, there's how we plug A into the equation. Okay. Okay, we are going to do just a little more with this function. Here's a graph. Can you estimate the zeros? What do I mean by zeros? I mean points where the graph crosses the x-axis, where the function has value 0. Okay, well, that would be this point and this point. Okay, so zeros are here and here. So given the scale that we've defined, what's the x-coordinate here and what's the x-coordinate here? Just write it down in your paper. Okay, now some people are having a little trouble with this, looking at the work. At least one person has their x equals 7 line. It doesn't go through the vertex of the parabola. So we'll fix that in a minute. The vertex is kind of our central point. So we want to draw a vertical line through the vertex and label it x equals 7. Somebody had the x, I forget, it was a little to the right or a little to the left. Doesn't matter. Okay. Now, if you have a copy of this, on my graph, the distance here is 7 units. It's from 0 to 7, right? So if I go the same distance, I'd have 7 more units, and x would be 14, wouldn't it? If I add 7 units to 7, I'm going to get 14. So on my graph, I would say that x equals 14 would be right here. Just doubling this distance so that the x equals 7 line is halfway between x equals 0 and x equals 14. Does this line look like it's about halfway between this one and this one? Actually, I think it's a little bit too far that way. So the 14 should be a little further out, but we're just doing a ballpark estimate. So if I do that and then do it again, I'd get a line for x equals 21. 21 way out here. So x is 14. It's between, well, sorry, the zero that I marked is between x equals 14 and x equals 21. Looks like it's a little closer to 21. So I'm going to say that this is x equals 18. This line right here. So at that point is 18, 0. This point over here, well, if x is 7 here, I go back here, 7 units would be about here. It looks like x equals about a little closer to 7 than 0, -4. So I'm going to let this one just kind of sit cockeyed. This over where it balances. So estimates. X equals -4 and x equals 18. Now, I made honest estimates there. I didn't figure anything out. But it turns out that those estimates make a lot of sense because x equals 7 is exactly halfway between -4 and 18. You had -4 and 18, you get 14, divide by 2, you get 7. That puts 7 right in the middle. And the reason that's important is x equals 7 is your axis of symmetry. Anything that happens on the right happens at an equal distance on the left. So if this point here is 18 units to the right of x equals 7, this point here should be, I said 18 units, sorry. X equals 18 is 11 units to the right of x equals 7. If we go 11 units to the left, we should get this point. And if you go 11 units to the left of x equals 7, you do get x equals -4. Now, that doesn't mean that my estimates are correct. It just means that they're consistent with symmetry. Find the actual zeros. And let's see, that is visible, yeah. We solve the equation g of x equals 0. And that would be I'll say meaning -5 over 49 times x minus 7 squared plus 12 equals 0. So how are we going to solve that equation? I'm going to go through it because we don't really have time for everybody to work it out. We've got about 10 minutes left. So I'm going to write the equation here, -5 over 49, and the negative sign should be out here maybe. And the 9 should be more of a 9, but there it is, times x minus 7 squared plus 12 equals 0. We have a denominator 49. We multiply both sides by that denominator. Okay. We multiply it by the denominator. We do 49 times negative 5/49 times x minus 7 squared plus 12 equals 0. Now, I've done such things many times. Make this 49 look a little better. We get 49 multiplied by negative 5/49 times x minus 7 squared plus 49 times 12. Shoot, I'm going to have to multiply 49 by 12. Well, I can do that. And I need an extra parenthesis here. Okay. When I multiply this 49 is going to be part of the numerator. This 49 is a denominator. So 49 is a factor of both numerator and denominator. Means I'm going to get negative 5 times the quantity x minus 7 squared. And 49 times 12 is 12 less than 49 times, than 50 times 12, which makes it 588. Okay, now check my arithmetic. I'm pretty sure of that, but I'm never totally confident. Okay. Be foolish to be totally confident. So we add negative 588 equals negative 588. Both sides, we get negative 5 times x minus 7 squared plus 588 minus 588 equals negative 588. Now, people are usually taught just to cross out the 588s here, and they lose track of what they're actually doing. Okay? So I emphasize what you're actually doing. You don't get to cross things out unless you know exactly why. And the exact why is if you write out what you get when you add the left-hand sides equal to what you get when you add the right-hand sides, this is what you get. You don't cross anything out. 588 minus 588 is 0. So it's this plus 0, so we don't have to write out either of those 588s. Then we divide both sides by 5. We'll divide by negative 5. And we get x minus 7 squared equals negative 100 and 17.6, but it's not negative because it's a negative divided by a negative. Okay. Pretty sure the number's right. So x minus 7 equals plus or minus the square root of 117.6. Square root of 117.6 is about 10.8. And boy, my estimates came out really close. Because if you remember, my estimates were 11 to the right and 11 to the left of x equals 7. And this says they're 10.8 units to the right and left. So, I lucked out, made a good estimate. Okay. Add 7. And we get x minus 7 plus 7 approximately equal, because we're adding two things that are equal to two things that are approximately equal. There are more decimal points here. So that X is approximately 7 plus or minus 10.8. That equals 17.8 or negative 3.8. Now let's make sure that my numbers are visible. They are. Just getting used to this camera. I like this camera a lot. We compare that with the estimates. X equals 18 and X equals negative 4. And 17.8 is really close to 18. Negative 3.8 is really close to negative 4. Now, the better you make the graph, the better you make the parabola, the better your estimates are going to be. The better you copy down what I draw. But if you're doing this in open math, you have a graph with a nice grid on it. You don't have to draw it freehand. I want you to draw these freehand though, because you learn more. And you reinforce it more if you do every step. So if you do every step of everything we've done here today, you have a really good start on what we're going to be doing in pre-calculus class. And maybe what you're already doing, depending on which class you're in. So I recommend that you give this really close attention. And I think I've used up just about all of our time. Yep, we've got 2 minutes left, and it's kind of pointless to do things in 2 minutes. So I'm going to kind of turn you loose on the next assignment, which is graphs of applications of quadratic functions. It's very important. Give it a reasonable amount of time and attention, and we'll talk about it more next time. Not particularly difficult if you get what's going on. And if you got a question, email me. I'm always glad to, or you can, you can post a question while you're working in open math. And sometimes I'll see it while you're still working, because I usually look at these things like, the evening before they're due, which is when everybody works on them. People should start them earlier. Yep. You learn more if you spread out the learning process instead of trying to do it all in one chunk. Anyhow, probably best to email me using your VHCC email. But it's also fine to do that through open math. I check the email more often than I check open math. Okay, again, if you have questions, get them to me one way or another. Of course, I got office hours too, so you're welcome to come by.